Welcome to episode number 7 of Conversations for the End. Today's guest is Dr. James Beacham. Dr. Beacham is a physicist, science storyteller, presenter, technologist, and filmmaker. He has spent the majority of his research career searching for phenomena such as dark matter and quantum black holes at the Large Hadron Collider at CERN. He is a co-recipient of the 2025 Breakthrough Prize in Fundamental Physics as a core member of the ATLAS experiment, one of the two teams that discovered the Higgs boson particle. In addition to his research, he speaks and performs around the world at the intersections of science, technology, politics, society, and art. He contributes to podcasts, radio shows, TV series, and documentaries, and appears in the popular press. James is an experimental filmmaker exhibiting at art venues internationally and collaborating with other artists. This was a really fun conversation. It's not often that little old me gets the chance to sit down with a particle physicist that played a part in discovering the Higgs boson particle. We talk about a lot of things. We talk about meaning, as a kind of hard scientist, and how James kind of finds that. We talk about, is our universe existing inside a giant black hole? We talk about Katy Perry being rocketed up into space and what are the ramifications of that for society. It's really fascinating. James has loads of insights. I really enjoyed this. I hope you really enjoy this. Listen, if you're listening on the audio platforms, then please head over to YouTube. You can watch the episode in video form there. I'll be doing some other video essay kind of stuff very, very soon. So subscribe. If you're watching on YouTube, then please head over to Instagram and follow us on there. We do like other additional kind of content on there that you can only see on Instagram. Okay. So look, I hope you enjoy this. Comment, share it with your friends, whatever you want to do. Be curious. Go. Yeah, listen to James. He's got some wisdom. Okay, hope you enjoy. Without further ado, Dr. James Beacham. Dr. Beacham, thank you for coming on the show.
Thanks for the invitation. I'm very happy to be here.
So one of the things that I talk about a lot on this podcast is the idea of disenchantment. And disenchantment kind of comes, as Carl Jung thought, from the birth of the Enlightenment and kind of the sort of birth of modern scientific thinking. And he thought that kind of held a lot of benefits and it brought a lot of progression to the world, but it did, in some sense, kind of strip the magic out of the world, de-soul the world is what he said, because of how we began to view the world. The world of modern science was a different way of thinking to kind of archaic man. But what he did say sort of later in life was that he thought that physics was the science that was actually, in a sense, attempting to bring some of the mystery and the magic back into the world. And you're a scientist. You work at the Large Hadron Collider. You are also a science communicator, and you sort of make these ideas accessible to people. I just wanted to get your take on that, really. Your view on the kind of, if you see there any mystery in physics, and do you see it as something that is bringing kind of magic, in a sense, back into the kind of hard sciences?
Yeah, that is an enormous mouthful of question. Let's put it that way. We could have several hours worth of discussion here. It's an interesting one too, because when I have read Jung and various people that have thought about these kinds of things much more deeply than I have over the years, And when we come across statements like that, removing disenchantment from the world in a sense, I, of course, think about it from the perspective of, because a lot of people, when you hear that phrase, right, it's like, oh no, the concept of disenchantment itself, right, which I think is really interesting. It's an interesting thing to talk about over multiple, episodes of a podcast. I look forward to diving into some of your older episodes. But when I hear about the concept of disenchantment, there's a huge amount, like so many things within modern society, and the way that we talk about things in a kind of, for lack of a better phrase, common sense way, that there's a large amount of assumptions that go in behind that phrase or that word itself. So, for example, when I hear the word disenchantment, or the fact that maybe science, by elucidating the way that the universe works, the way that the world works from a purely naturalistic perspective, has somehow led to disenchantment for humans, I would ask the question, why were we enchanted to begin with? Because I think there's a lot of assumptions that go on, behind that question. So, this notion of being disenchanted meant that there was some kind of, tacit acknowledgement, or it's implying that there was some kind of tacit acknowledgement of some kind of enchanted world, or some kind of, again, for lack of a better phrase or a word, supernatural, some kind of out there ideas that are more than just a purely naturalistic viewport of the world. And those, once you ask that question, and once you dive a bit behind the question, you realize that, humans, as the way that we evolved as a species, in this very kind of social way to, also invent these kind of thought processes, these kinds of structures that are philosophical and end up being very religious and spiritual and supernatural. These were there for a reason. These were there for a social reason. So, this notion of disenchantment, I mean, I personally don't experience it, because, I think of, to finally get around to answer your question, science itself is absolutely enchanting in the sense that it enables us to use the basic tools that every single human being uses every day in various ways: logic, reason, the recognition of the existence of a shared reality, a more or less objective shared reality, and a reality of which we are all a part. And then it puts these in a very controlled way to allow us to make statements about the way the universe works based upon the best information that we have now. And that is, in and of itself, absolutely enchanting. The fact that that my astronomer colleagues can look up into the sky and they can actually go through the thought process and say, wait a minute, it's the first order kind of very selfish, very, anthropocentric thing. It's like, oh, we're obviously at the center of the universe, and, God made the universe for us, whatever God means, because humans have espoused something like, 5,000 official deities throughout their history. So, God made the universe for us and everything's going around us. And they can say, actually, that's not true. That's absolutely enchanting to me, because it's taking away from some kind of, darkness, some kind of throwing up your hands, some kind of like, well, we don't know anything and we'll probably never know. That to me is capitulation, and that to me is quite bleak. And I think, for example, I think Douglas Adams probably said it best, something like, I'll take the awe of understanding over the awe of ignorance any day. And so, I mean, it's a kind of a long way of answering the question, but, that's what I think about when I hear these kinds of concepts.
No, it's the awe of understanding. Yeah, I think I had Simon Augusta on the last episode, and he said something that kind of made me think of what you were saying there. He was talking about the sort of progress of culture and humanity, and he said the fact that we have like an iPhone in our hands and we take that for granted. It's like, not long ago was it sort of sticks and dirt, and I think you're kind of touching on the wonder and the awe in humanity. And I've heard you say something along the lines of, you find kind of wonder in the ability of human beings to find intuitive ways to do impossible things. I think it was something along those lines. Yeah, and I think, yeah, you're right. There is an enchantment in that. I want to touch on sort of going adjacent to that idea. What you're saying there, it all makes sense. And it seems like that's something, as working as a scientist over time, that you would just more and more would be sort of reaffirm to you the work that you do. It kind of, you see that in action. You talked about in a Q&A when you were a kid and someone asked you for advice, who, if they wanted to get into science or be a physicist, and you said it kind of calls to you, science calls to you. And could you just expand on that a little bit? Because I just want to know, as a child, when science called to you, kind of what that looked like for you in that sense.
Yeah, that's a really good question. So for me, I think typically what I think about when someone asks me that question is I I think that physicists, let's be clear about what we're talking about, right? Science is this enormous banner of the best way that humans have, and in fact the only real way that we have to ask and answer questions about the universe in a way that we can lead to robust, repeatable, reliable answers about the way the universe works according to our best understanding and data right now. That's the big banner. But then within science, of course, we have physics. And as a little kid, I was one of these sort of voraciously library-bound kids, and I was constantly questioning things and asking questions. And when I couldn't find answers to the questions, I would go to the library, and that was the place to find all these things. And so I was obsessed with a lot of different things. I liked all the sciences, but the thing about physics is that if you're the kind of kid who thinks, wow, these animals are amazing, I want to learn about the taxonomy of this, blah blah blah, you end up in zoology or biology or something like that. And if you're like the kind of kid who's like, wow, this is really fascinating, how like I can look deep inside, and there's little cells in here and the way that they work together, and then you'll become a biologist or a geneticist or something like that. And then if you ask the question, it's like, but what's smaller than that? And you get down to molecules and things, and like, wow, the way these work together lead to chemicals, and you'll be a chemist. But if you keep going, if you keep following this logical progression all the way to the very edge of our human knowledge, you ask, what's smaller than that? What's smaller than an atom? What's smaller than an electron? You get to the point where the answer is we don't know, and in fact, there's probably nothing smaller than an electron. That's the place where the physicist ends up naturally going. It's not as though there's a there's like a kind of born physicist and only those people go to that edge. I think everybody has the possibility of following this logical progression to the very edge of our human knowledge. But the physicist is the one who refuses to accept any of the kind of the answers that come before then. So I like to say that typically people don't choose to be physicists. It's more like physics chooses us, because physics is just the word that we assign to this kind of controlled study of the very edges of human knowledge. And so this is interesting because, maybe just to kind of jump back to the previous question you asked, is that, because I was thinking about it a bit more, reflecting as we were talking, and, in terms of introducing more enchantment back into the world, again, like I said, number one, I don't think we needed to be enchanted to be in the first place. And if we were, that was strictly a consequence of the way that humans evolved in societies and needed in groups to people they could trust, things like that, but in addition to that, if there was some kind of magic that was lost due to the Enlightenment era thinkers or the scientific revolution, whatever you want to call it, where science became the prime way of constructing knowledge about the universe. And that's very explicitly, in another way, that's what science is, right? I mean, in German it's Wissenschaft, which is the construction of knowledge, and that's really what science is. Then yes, in the sense that if you're the kind of person, or if you're in fact the kind of power holder within a society where for example the priestly class had all the power, and suddenly there was a competing and in fact superior way of explaining the world that was repeatable and reliable and robust, that was called science, then you did lose a bit of your power, and you were losing a bit of the enchantment and losing a bit of this ability to exist in the sort of gray areas of human existence, and insisting that there's something going on there that we can never know, this kind of thing. Then in fact, yes, what physics does, and as you know, 100 years ago with the construction of things like quantum mechanics and quantum field theory, it reintroduces this. In a sense, I don't think it's exactly the same. It's not exactly analogous, but it reintroduces this in a very explicit way because of these uncertainties that are built into quantum mechanics, which, as you know, It's one of the things that is just so alarming about quantum mechanics is that it has these uncertainties built into it, and which is very strange for our human sort of, again, animal brains, where, again, if you feel like science is this thing, and again, like I did this as a kid, science is supreme, it can explain everything, da 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 da, and we can know everything. Once you get a little bit farther into it, you realize that the most fundamental way by which the universe works, which is quantum mechanics, quantum field theory, necessitates that there are limitations to our human knowledge. And as you know, this, for example, the uncertainty principles, if you have a couple of different variables that you might want to measure, and you might want to measure them almost, arbitrarily precisely. In fact, if you know one of them extremely precisely, you don't know the other one nearly at all. And if you know the other one extremely precisely, it's the other direction. Introduces a necessary uncertainty. And again, this notions of the limits of human knowledge, it demonstrates that our conception of human knowledge is necessarily limited, and it always will be. There are certain things that we will never be able to know, full stop. And if that's the case, then the philosophical parts come in, as what does it mean to know things? What is the nature of reality? We talk about epistemology and ontology. These are fascinating concepts because they're baked into quantum mechanics. And so, in a sense, that is a way to, if somebody needs that in their life, if they need some kind of concept of like, oh, there's unknowable things. It's not exactly what we're talking about, but built into quantum mechanics, there are limitations to human knowledge.
And I think that is, at least my intuition of it, is I think why Jung made those statements is it's a world of paradox and, limitation, and, many parallels there. The idea of, that you were talking about, your own journey into sort of particle physics is going deeper and deeper and deeper and deeper, and Jung would be a proponent of that for the psyche, but also the idea of there are some things that we just cannot know about ourselves and the world. So,
and to actually answer your question personally, I do remember there was not necessarily one kind of light bulb moment for me. Like I said, it just sort of becomes inevitable after a while that you're going to go into physics if you're a physicist, because you just keep getting drawn back to these very edges of our human knowledge. But I do remember one time when I was a kid, probably several times, I loved my mother's baking. She would make this amazing bread, and as a very little kid, I would look at it. I would see her make it in the dough, and then she'd put it in the oven, and then I would apparently I would go up and look through the oven, and I would just constantly be asking, "Is it done yet? Is it done yet? Is it done yet?" And she was like, "No, wait a little bit longer." Finally, when I got a piece and it had to cool down a bit because I'm still a little kid, I'm going to try to eat it when it's extremely hot. I would eat it and it was delicious, and then I would eventually start looking at the little crumbs, and I would kind of like tear the crumbs apart, and I would ask, kind of like, I would think about how small I could possibly go, right? And that was just something that kind of like comes into your head. And then I didn't have an answer to it when I was a tiny child because I couldn't even formulate the question. Then later I started to formulate the question. Then I go to library and look up, the entry in, about electrons in the, World Book Encyclopedia or something like that, and start to get a better sense of, what our knowledge of that is like. But that was one of the kind of moments for me. And it was, again, just a kind of quotidian thing. We as humans, we, evolved in this particular very friendly, very, very nice energy range within, a very nice planet that is extremely luxurious compared to basically everywhere else in the universe. Overwhelmingly, the universe is not like what you and I experience and the way that our species evolved. And so it makes sense that, just to kind of go back to the first question too, in a way, it makes sense that we did have this kind of concept of an enchantment or this desire to explain things in a way that, postulates or posits some kind of extra kind of thing that's controlling things. And, maybe it's a bearded white man that lives outside the universe and judges you, when you're doing things, or whether it's some kind of like, hippy dippy idea about, like a cosmic consciousness. Those things kind of made sense for our species the way it did. But we know that the universe is not at all, overwhelmingly statistically, not at all like the way that you and I evolved. So it makes sense to me that there would be this bit of a gap. And of course, navigating that gap as a human is part of what the human experience is about.
Yeah. I'm just trying to figure out where to go now, because you touched on something there that I do want to touch on, but I don't want to go there yet. But I am going to come back to it. Okay, so you'll find out shortly. Okay, one thing I'm sure you've talked about a lot, and there are videos online. I encourage everyone to go look at your talks because they are absolutely fascinating. And I love the way you deliver them. There's a lot of story in the way that you tell things, and you communicate very complex ideas in a very accessible way. And I think when it comes down to particle physics, for lots of people like me, that's needed. So I appreciate it. But please, can you just tell us about the possibility of our universe existing inside a black hole?
Yes. How much time do you have? Now, I'll give the sort of more than executive summary version. So this is interesting too, because one of the talks you're talking about is a talk I gave at the Royal Institution in London a few years ago, and it was about the title was ostensibly something like the other end of a black hole, and I. In this talk, I do talk about black holes and what they are and where, what the concept comes from and, explaining the basic physics behind them. Excuse me. And then at one point, I do kind of dive into this idea that it's entirely possible that our entire universe is inside an enormous black hole. And that kind of makes no sense at all for the first time you hear that, because it shouldn't make no sense. Because, again, what is a black hole? A black hole, just to be clear what we're talking about, a black hole is, from a physics perspective, it's a completely gravitationally collapsed object. That is not the correct way that most people need to think about it, though, because it doesn't make any sense. Instead, you can think about a black hole as the logical conclusion of what happens when gravity happens. So what is gravity? We know that gravity is one of the four fundamental forces of the universe. There's only four that we know of, and three of them you know quite well. These are electromagnetism. One is called the weak force, and it's mostly best known, you might know it best as responsible for radioactive decay. And it's also the way that the sun burns, et cetera. And then there's one called the strong force, and this is the one that holds, quarks and gluons stuck together into protons and neutrons inside your body. And there's a residual version of it that also holds the protons and neutrons stuck together. So it's very strong. And then the one that's not part of this is called gravity. So the weird part is that three of those forces, they function due to the rules of quantum mechanics. And we can get into that later. But gravity does not arise that way. Gravity has a totally different mechanism by which it arises. And it arises due to the fact that empty space, is not really such an empty place. In fact, space has a kind of stuffness to it. It doesn't have a substance, but it has a kind of stuffness to it in the sense that space itself can bend and it can flow as well. And this was a wildly bizarre postulate. And what that meant is that, this is the way that gravity works. So it turns out the more stuff you pack into a given volume, the more space bends and eventually starts to flow toward the center of that volume. And if you take that to it, so for example, the Earth has a certain density in it, and it's pulling you to, and you are in fact falling into this three-dimensional gravitational well that has created this kind of sinkhole in space created by the Earth. Same thing with the moon. The moon is also kind of constantly falling into this sinkhole. It's the same thing with everything that happens, that interacts via gravity. So if you take that to its logical conclusion, the more stuff you pack into a fixed volume, the denser it is. That means the more gravity there is, that means that the more space bends and starts to flow toward the center. So a neutron star is much, much denser than the Earth. And if you were there, you would be, crushed into a pancake or something. But if you take that to its logical conclusion, in fact, if you look in the equations of general relativity, if you pack too much stuff into a fixed volume, space will be flowing into the center faster than the speed of light. And this makes no sense to, when the first time you hear it, because of course we've all been told nothing can move faster than the speed of light. That's absolutely true for things like you, matter, information, light, but just, it's in the word, in the phrase speed of light, right? So this is true for these things, but in fact, there are phenomena, there are occurrences that in fact from one perspective, can be thought of as moving faster than the speed of light. And this is the case with the flow of space. So this is why we talk about how not even light can escape from a black hole. So you can think of a black hole in space like an extremely strong water drain. If you've ever seen these videos of, say, Lake Berryessa in California, it's a big reservoir, and they have a dam there, but they don't let the water through the sides or out the bottom. In fact, there's a little bit of a funnel right there, and when the water level gets up that high, it starts to go into the funnel. So imagine if you're a fish in the water. If you stay far enough away from this little drain, this funnel, you're fine. But once you get too close, the water will be flowing inward faster than you can possibly swim. And even if you swim at your fastest possible speed, you'll be sucked into the drain. So this is what a black hole is. And this is how gravity works. And so it turns out that you can just do, in fact, there's a black hole equation. Everybody can look it up themselves. I mean, just take the textbook on gravity on your bedside table. I assume you have a textbook on gravity on your bedside table like I do. Pushes up his glasses like a nerd. But you can just find the black hole equation, right? And it tells you very explicitly what size of a volume you'd have to pack how much stuff you'd have to pack into a certain volume to make a black hole. And we can do this out of everything. If I wanted to make a black hole out of your body, I would need to pack the whole thing into a volume that's smaller than a proton. So you're probably safe. We're not going to make a black hole out of you. If I wanted to make a black hole out of the Earth, I would have to pack the entire Earth into a volume about the size of a blueberry. And I love blueberries, but that's not going to happen anytime soon. We're not going to be able to make a black hole out of the Earth. But it shows you the extent to which you'd have to go to make a black hole, the kind of density needed. However, you can also do this with larger things, with the sun. If I wanted to make a black hole out of the sun, I need to pack it into a volume that kind of goes around the center part of London, And you could also do it with extremely large things, like, for example, the observable universe. So we know that the universe, when we say the words the universe, we typically, and again, in a philosophical sense, we're talking linguistically and philosophically about all the stuff that exists, everything that exists. It's a very kind of provocative ontological statement to use the word universe and then try to define what that is physically, but we can. We know for a fact that there's in fact two different things when we say the word universe. We have to say that there's something called the entire universe, which we have no idea how big it is, because there's something within that, a subset of this universe called the observable universe. And the observable universe consists of a sphere centered on you, and for all intents and purposes, centered on us here on the Earth, that contains all of the stuff in it that has sent a light signal, that has had time and has had the proper conditions of being able to flow through space, that has had time to reach us yet. We know there's stuff beyond that, but all that we can verify that exists is this observable universe. And we know that the observable universe has a size. And my astronomer colleagues are extremely good at estimating how much stuff is in the universe, how much mass and energy density there is. Excuse me. How much mass and energy there is. And if you add up all that stuff, you've got some enormous number, like, I don't know, I forget what it is, 10 to the power 45 kilograms or something insane. It's some enormous number. So you might think, okay, what size of a volume would we have to pack the observable universe into to make a black hole out of it? And it turns out that if you do the calculation, you would need to pack the observable universe into a volume that's already larger than the known volume of the observable universe. And just like you, the first time I saw this statement made no sense. And I think every physicist, when they first hear this, they think that's obviously not right. And they go and do the calculation themselves. It's not a hard calculation. And then you do it again. You're like, And then you get Wolfram Alpha to do it just in case you miss something yourself. And so there's various ways you do this. And then once you actually do the calculation, you realize this is entirely true. It's a very bizarre statement, I realize. But it also, because again, this thing that we talked about, a black hole, is this point in space where there's so much stuff flowing, there's so much gravitational pull that space itself and anything within that space is flowing toward the center faster than the speed of light. And in fact, in smaller black holes, say, the black hole that would be the the sun mass black hole around the center part of London, the gravitational conditions there are going to be extremely extreme. That's a really nice redundancy. Like if you approach this black hole, in fact, the gradient difference between the gravitational pull on your head and the gravitational pull on your feet would in fact, even though you're not very big, you're not very long, it would be so extreme that you would probably get stretched into spaghetti as you get pulled into this black hole. And this is in fact what my astronomer or astrophysics colleagues refer to as spaghettification. And this is known to well, not known. It's suspected to be the case for these kinds of black holes. However, and so you might think, okay, a universe-sized black hole. If we're in a black hole right now, man, I'm not spaghetti. I'm fine. I've never felt this gravitational pull. Nothing like this. And so you might think that's a crazy idea. But it turns out that if you have a large enough black hole, it ends up being kind of an academic idea. So if I had an enormous black hole, forget about the universe mass black hole, just some enormous black hole like a galaxy-sized black hole, right? If I were to pass into that with my spaceship, as I passed over the event horizon, which I'm sure you've heard about as kind of the point of no return, beyond which there's no possible trajectory for you to ever, even if you're going at the speed of light, to ever get outside of that horizon again. If you pass over this event horizon, there will be, in fact, you probably wouldn't notice anything at all. This, again, requires you to have a very large enough black hole. If you had some gravitational device to be able to measure what directions you can possibly go, it would always be pointing toward the center of the black hole, but you'd be fine. You just hang out there. And again, if it's a large enough black hole, you could kind of do this indefinitely for your entire life. So then if you extrapolate this to the enormous universe, observable universe mass black hole, you start to think how this could actually be a possibility, right? We think, okay, it still seems weird, but okay, it's like I'll take your word for this one on this one, James. But then, how is this even like? How can I wrap my head around this in a kind of in a sort of understanding way, right? You think about what it would be like if you were inside an enormous black hole in your spaceship, right? You pass over this event horizon, and your little magic, not magic, but your little special gravitational sensor tells you there's no way for you to ever go that direction. It's always going to go this way. It's always going to go this way. You're like, okay, that's what my meter says. And what you would in fact experience is that what that means is that there would be a horizon, there would be a point in space around you beyond which you could never go. And in fact, is always getting slightly larger because more stuff is coming into this space, right? You're coming into this black hole. But no matter how quickly you traveled and no matter what you did, there's no way for you to ever get to that horizon, which is what a horizon is, kind of the definition of a horizon, right? It's like if you're on the water, what is the horizon? It's the place you can never get to because it's always in the distance, right? So that's what you would experience inside an enormous black hole in a spaceship. Now think about what it's like for you and I here on the Earth, right? We are here on the Earth, everything seems fine, and we know that there's a horizon far, far, far away called the cosmological horizon, beyond which we know there has to be stuff out there, and it's slowly always getting larger, and more stuff is coming into view. If we as humans lived for 1 billion years, that we could start seeing really cool things 1 billion years from now that are just coming into view. Excuse me. But no matter how quickly we traveled, we would never, ever be able to get to that point and traverse it and to go the other direction. So, it's a wild concept. And it's also one that, the first time you kind of encounter it, you're like, oh, I don't know. I don't understand this. Is this just physicists being like crazy? And are they busybodies? Should they stop thinking about things like this? But I find it a fascinating thing to speculate about.
100%. And I know you maybe, however you feel about it, but it is enchanting. I will say that much. The thing, okay, so I just want to try and understand it a little bit more. So if I ask, I know you're going to say there's no silly questions, and I respect that, but if I ask a silly question, yeah, just help me out with this. So the cosmological horizon, right? Like, that is what we know as the expansion of space that is moving exponentially outward, arguably from the Big Bang. Is that correct?
More or less, yeah.
More or less, yeah. Obviously, yeah. That was very kind of you to say more or less. And you're saying that could theoretically be the event horizon, the tipping over point of the black hole.
Not necessarily. So this is where it gets a bit weird, because yes, what you're getting at, I think, is the thing that the cleverest amongst us will definitely get at, right? So, for example, you ask the question, okay, so James, uh, inside of a black hole, forget about the universe black hole for a second. Inside of a
Mm-hmm.
black hole, at the center, there's supposed to be something called a singularity, yeah, and the singularity is it probably doesn't exist. One of the things about black holes is that they are the place where two of the biggest, two of the most successful intellectual achievements of humankind come together: quantum mechanics and general relativity. These are two of the pillars of modern science. And the bizarre part is that when you try to kind of combine them, assuming there's some sort of behind the scenes theory of everything goes crazy. We get insane answers like infinite energies and probabilities greater than one, which doesn't make any sense. And so people have tried to put these things together, and they necessarily come together in something like a black hole. And so at the center of a black hole, the naive version is that there's a point there that makes no sense. It's a point called the singularity, which is not the silly thing where it's like, oh, AGI is going to just suddenly change. No, that's not what we're talking about. We're talking about the fact that there's a point where you have infinite density and infinite curvature. And I don't even know what that physically means, and I'm a physicist. So probably our universe wisely avoids singularities and these kinds of infinities because they don't make any physical sense. And there's probably some theory, some theoretical understanding that we'll jump in to help us explain this once we ever, go travel to a black hole and go into the center and somehow figure out how to give that information back to the rest of us. Or maybe we make black holes in the laboratory and able to little ones to be able to study the phenomena there. And so the center of a black hole is a singularity. But then you might ask the question, if we're in an enormous black hole right now, where is the singularity in our universe-sized black hole? Which is not exactly the question you asked, but it's similar in a kind of like inverse way. Because within a regular black hole, right, we would have a singularity, and your little gravitational sensor would be pointing toward it. It's like, oh, that's the only trajectories you can ever possibly go are that way. In our universe black hole, it's like, where is the singularity? Well, there is no singularity within our universe-sized black hole, if in fact we do live in a black hole, because you have to kind of think about it in the sense that we have both. There's both a spatial component and also a time component to general relativity, right? So if you're in a regular black hole, you have this kind of extreme spatial curvature, but also time starts to change a bit too. So if you squint and kind of turn things around a bit, you realize that, in our universe, perhaps this sort of extreme event, the extreme curvature part, may have corresponded to the Big Bang 13.8 billion years ago. And instead, as the universe has expanded, it has ended up washing out this entire thing. And that kind of makes no sense. But think about what happened when, you mentioned the expansion of space. 13.8 billion years ago, what happened to make the Big Bang bang? And what does it mean for the Big Bang to Big Bang? And what does it mean for the universe to expand? It's a similar question to someone would ask, where in the universe did the Big Bang happen? And the answer is that it happened everywhere at once. In fact, that's what we mean. So, the Big Bang was an insane thing. We had basically everything in the universe. We know that the universe is expanding. My astrophysics colleagues or astronomer colleagues are very good at, seeing how fast things are moving apart from each other, all the galaxies. And we can estimate how fast that it's moving apart. And we know that everything is moving apart from everything else. That means if you just go backwards in time, at some point, everything had to have been packed into a tiny, dense little point that then started expanding. But that expansion was just a crazy thing. And in fact, it went from something tiny to something macroscopic in some crazily small amount of time, like 10 to the power minus 34 seconds or something like that. It's similar to if you and I, if we took a horse right now and we magically inflated it to the size of the known observable universe in 10 to the power minus 34 seconds, that's kind of what happened at the very sort of inflationary moment of the Big Bang. But after they did that, it went down to a much more gradual expansion rate, but it's still quite fast. And it's been doing that forever. So in a sense, that point, and again, we can talk about limitations to our knowledge, and also it's we could have an entire discussion about the concept of time and what happened before the Big Bang. And in fact, that question itself is probably not even so well posed. There might even not have been a t equals 0, because time itself as a phenomenon may have arisen simply due to the expansion of the universe at the moment of the Big Bang. So there might not even be a t equals 0, or let alone a t equals -1. Anyway, but if you think of it from that perspective, you kind of twist your understanding, you would twist the question. It's like, in fact, the sort of singularity in the universe-sized black hole was the time of the Big Bang, and then it ended up, as it got expanded into the entire universe, as it expanded, we have a sort of, the entire universe itself is the substance of the inside of a black hole. So you can realize that when we say the words, maybe the universe is inside an enormous black hole, it's not so straightforward as just saying there's a center somewhere within our universe, and everything is moving toward that on a large enough time. If you were sort of, again, back to the concept of deities, if you were some sort of deity looking outside of the, like the universe or the multiverse or something, it's like, oh, look, their little universe part is inside a black hole, and from my perspective, it's moving faster than the speed of light towards something. That's probably not what we mean. What we mean instead is that there's this kind of duality of, I guess duality is the wrong word, but space and time being connected. And if you have a kind of singularity in one realm, it also implies a singularity in the other, or vice versa. So it's the long way of saying that there is no real singularity in our universe in the way that we think of the regular universe is. The regular black hole would have a kind of singularity inside it. And yeah, sorry, go ahead.
No, finish.
No, and so as a result, that it's not so straightforward to just answer the question. Instead, sometimes we have to kind of take the question and twist it a bit and realize that maybe the insight to understand it is by posing it in a slightly different way.
So if the universe were in a black hole, we should not think of it like a ball in a cup. It's not that kind of it's like, yeah.
Not necessarily. Yeah. I mean, again, when we think about when we talk about the edges of science, and especially the edges of fundamental physics like general relativity and quantum mechanics, we have to kind of change our brains a bit to sort of to allow this other kind of more complex understanding come in. Because again, like we talked about earlier, these things seem counterintuitive to humans. And again, a lot of people talk about, to go to quantum mechanics for a moment, a lot of people talk about the weirdness of quantum mechanics. I mean, that's a statement that is another statement of the limitations of humans and the way that we evolved as a species. I mean, the universe is under no obligation to make its laws seem elegant to humans, right? That's not what the universe again, the universe doesn't even nearly acknowledge that we exist. We are embedded within the universe, and long after our species has ceased to exist, the universe will continue, possibly infinitely. And so there's no reason for us to think that, the laws of the universe as we are learning them should somehow make intuitive sense to this primate species that happened to evolve very recently in this kind of like very friendly energy range. There's no reason to think that. So very often what we have to do is we have to kind of dive into the details, realize that our understanding is very limited as humans, and instead twist it a bit and realize, okay, the real insight is there, which is, if you really want to super know the details, that's what graduate school is for. You have to dive into a graduate program. You have to do years worth of quantum field theory calculations and, calculate the triangle anomaly in QCD and blah, blah, blah. So that's if you really want to know the details, but to get a sense of it, you just really need to instead, think about the concepts, think about what it is that we're really asking when we ask one of these big questions that seems straightforward in one realm, but in fact, it's you can elucidate the understanding a bit better if you think of it from a different perspective.
So I think it's good advice generally to be thinking about the things that our presuppositions to stuff in our language and in our thinking. Look, I'm going to be honest, James, I don't understand it fully, but I will say this, is it makes me so intensely curious. And I know that I want to go and look at more of this, and I want to look at stuff that I wouldn't necessarily normally look at, just to, I guess, experience that kind of, that awe of, the human ability to try and understand things.
Well, one of the things that I worry about a little bit when I talk about this concept in public in the the universe in a black hole idea, and again, it's not just me. I mean, I didn't make this insight. This is just part of Einstein's equations. You can kind of do this yourself. The thing that I worry about is that it will end up maybe taking a little bit of the magic away, but when people realize that, okay, in fact, the statement itself is really not so sensationalistic, right? The first time you hear it, it's like, wow, the entire universe could be inside an enormous black hole. But then practically, it doesn't mean anything to us because we're still going to be fine. Whether that's true or not, the Earth is not suddenly going to be like twisted into something and then turned into spaghetti. It's really going to be the same. And so instead, it's actually more of an interesting statement about the nature of general relativity. And when you go to extremely large scales of general relativity, the fact that from a technical perspective, the fact that the size of the observable universe and the observable universe's Schwarzschild radius, these two radii are similar, is not such a profound statement. And I don't know if we have time to get into that here, but it's just this notion that this is more of an insight about the way general relativity works on very large scales. Than it is, some kind of sensationalized thing about like, we're in a black hole, man.
Yeah, and I wonder, that kind of sensationalism of it and how people, pardon the pun, gravitate towards it. What is it about black holes that you think captures kind of the culture, that captures the cultural mind? Because there is something about a black hole that people do, I don't know if resonate is the right word, but they are drawn to it as a kind of this symbol of something. And, things come to my mind. I don't know whether it's the limits of our knowledge, like you say, like the sheer image of it, this kind of hole in the fabric of space time that goes where we don't know, and the kind of sheer size and scale of it. And I don't know whether it's the fact that it's just a hole and human beings, like historically evolutionary, try to avoid holes, and it's the ultimate of holes. Well, but falling down them, right? Falling into them.
Yes.
And I think that kind of element of it. What do you think? These are just the things that spring to my mind. Do you think there's something about it that captures the cultural imagination?
Yeah, I think that your insights are totally accurate, and I've thought the same thing a lot. It's like, why are we so obsessed with black holes? And I think a lot of it is what you said. There is this kind of like historic and maybe evolutionary reticence to to get close to a hole because of falling and things like you just said. But I think but if that were the case, then it would not be, people also, you can, see, people are also fascinated by, news stories of some weird sinkhole showing up in like the middle of a small town in Britain, right? And it's like, you got all these British grandmothers standing nearby, and there's this bizarre hole that just appeared out of nowhere. There's like a truck that falls in or something like that. But we're not sort of fascinated by that. We're interested. It's like, because I do the same thing. I'm like, wow, a sinkhole, that's totally bizarre. And then you start thinking about the underground aquifers and the way, things have happened, and the, fracking, the way this affects the geology. But it's not the same kind of visceral sort of thing as a black hole, because I think part of it is that, number one is that black holes are so remote and they're so far away that it allows us to be fascinated by them and kind of get toward the sort of dangerous nature of them in a safe way, in a comfortable way. We can speculate about black holes, and it's like, because we're never going to experience one ourselves. Well, there's some caveats there with particle physics, which we can go into, but we're never going to go to a black hole ourselves. Maybe your great granddaughter will do this. But the other part is that it's at least from the scientific perspective, those that think about it, if you have a good description or a better understanding of what a black hole is, it is this, like we said before, it's one of these extreme examples of the limitations to human knowledge and experience. And that in and of itself is fascinating, right? It's like the sort of like the forbidden fruit, or the again, this notion of back in like religious communities or spiritual traditions, where it's like there's this veil and you can never pass that. And if you once you die, there's some version of you, some ineffable thing that then passes, and you can't know that when you're alive, that kind of a thing. There's always this notion of something being not forbidden, but excluded from you. It's being hidden from you. And a black hole is kind of the ultimate physical version of that. Like we said, you can go over the edge of a black hole, but once you do, there's literally no way for you to ever go back the way you came. None. And so that, and there's also this notion of the uncertainty of, what's in the center of a black hole. Like I said, the sort of naive, plain vanilla version is that there's a singularity, which our universe probably wisely avoids these singularities because they don't make any physical sense. So there's probably something else that we need to understand. Again, we can talk about wormholes and how in some solutions of general relativity, the center of a black hole could in fact be a kind of, interstellar movie like, portal to another part of the universe. Probably not going back in time behind your daughter's bookshelf, but hey, who knows? There are these possibilities. There are other things there, but for a black hole, it's just such an extreme one-way street. It's such an extreme version of this sort of emptiness, and the most profoundly empty thing physically that you could ever literally think of or conceptualize. Like that's it. And that, at least that's for me, one of the series of things that are so fascinating about them. Scientifically, they're fascinating for so many reasons, but just viscerally for me, as someone who also has, say an artistic practice and has long been obsessed with art and culture as well and literature. This is such a huge, I guess, when you look into the abyss, the abyss looks into you as well. So I think that's kind of, the black hole is the ultimate abyss.
Yeah, and I think when people, I guess human beings generally, think of a lot of these ideas and they contemplate on death and things like that, the great beyond, the unknowable, it is sort of abstract, and you can think about it in lots of different ways. But to see that image of the black hole, it's this idea of there it is, like that's a physical thing out there. And you're right, I guess. I've never really thought about that, the distance, the fact that it's so far away, and often we can't even contemplate the sheer size of the universe. I once was in a hotel with my dad. My dad is in his late 70s now, and there was a documentary on the universe on the television. I think we were in Cuba or something, and it just did one of those, told you the scale of the universe in comparison to like the solar system, and he had to turn it off. He got like very, very anxious and was like, I don't like that. And I think it is maybe one of those things, like you say, the abyss looks back. It's you think about it too long. It's to see it physically and to ponder it. Okay, so I'm aware we're sort of running for time, and there's a few more things I want to ask you. So I'm going to sort of weave and segue through this. I'd like to know, obviously, you still work at the Large Hadron Collider in Switzerland. Is that correct?
Yeah. Yes. In fact, I'm sort of in a transition moment. I have for a few years. This is just sort of academic in a way, but for a few years, I've also done some kind of consulting work on the side for science communication and data science and things like that. So I'm sort of in a kind of exploratory mode where I've been doing some work with in the private sector as well. But yes, I still have a leg in that research. And in fact, I will brag that I am the co-recipient of the recently announced 2025 Breakthrough Prize in Fundamental Physics. This series of prizes by Yuri Milner, because I'm a member of the Atlas collaboration.
Yes.
And so when I say that I'm one of the awardees of this prize, there's something like 10,000 people that got this, but every single one of us should have this on our CV.
Well,
so, yeah.
Congratulations.
Thank you.
So that was the context, right? And the thing I do want to try and get to is, James, I'm going to put one thing to you. And I think when you start talking about building a giant, colossal Hadron Collider on the moon, people are going to think that you are either working for a Bond villain or you're maybe turning into one yourself. And I think you just need to be careful. But however, what I will also say is, in fact, your point of view is very much on that we need to kind of reclaim the moon as ours, right? We need to not leave it to the billionaires. And I wanted to touch on this specifically because there's been a lot of dialogue this week about Katy Perry being rocketed up into space and Jeff Bezos' wife being sent up into space. And it seems this kind of let them eat cake kind of the way people are living their lives, people weren't overly pleased by this. It wasn't something to be kind of celebrated necessarily. There are already lots of fantastic, amazing women astronauts who have gone up into space, and I think people maybe just did not see it in the way that perhaps it was wanting to be seen. Can you just talk a little bit on this idea of, I guess, the kind of capitalism hijacking space? You know, this idea. Do you see that as a real tangible possibility? Because it sounds sort of crazy to think Jeff Bezos might buy the moon, but it could only be a few steps away from the rockets and everything else. Could you just talk a little bit about your thoughts on that?
Yeah, I mean, so first of all, let's just make it extremely clear. It's obscene that we have a society where a few dozen human beings hold more wealth than billions of the rest of us combined. That is just quite possibly the most obscene thing that a person could conceptualize socially. It makes no sense. And the fact that we have subsets of society that try to convince us that it's somehow natural and okay is an extreme indictment of the way that we have allowed our social and economic systems and political systems to evolve over the years. It's of course tied into the climate collapse we're seeing right now, but it's arguably just as horrible a thing that we've allowed to happen as the climate collapse. And of course, these things are connected. And so, I, like many people, I'm horrified by the fact that we seem to be simply giving, space, the moon and Mars to these wealthy private corporations and individuals whose real only motives are extraction, exploitation, and profit. Because, what was the Blue Origin space flight, quote unquote space flight? This was not to inspire women to go into science. This was not to make people think that eventually it's going to be possible for you, the regular person, to go into space as well. This was an advertisement for Bezos and his companies and his financial and business entities. That's all it is. It's the same thing. It's the same kind of thing that is this extremely obscene. Again, you mentioned capitalism. It's extremely obscene thing that capitalism allows these people to do. The lucky winners to do. It allows them to hijack the concepts of charity and philanthropy and morals and whatever to pretend that things that they are doing are in fact for the public good or for the good of humanity, when in fact they're just advertising for themselves. It's the same thing that Bill Gates does. The fact that Bill Gates gets any kind of attention at all for humanitarian work is also equally obscene, because he's not doing humanitarian work. He's not trying. Number one, he's not elected. He's not an expert in these things. He's not an expert in virology. Why is anyone listening to anything that he has to say? If you scratch a tiny bit under the surface, you realize that, the reason why he's interested in, say, he's interested in eradicating different kinds of public health crises or being involved in public health crises is because he has a vested interest in the concept of intellectual property retaining its robust recognition within international law, because that's all that that's his entire wealth is based upon that. Microsoft, number one, it's really, really terrible software. But the fact that it's just infinitely replicable means that he has to tie something to it, that he has to assign something to it that makes it so that it's possible for him to make money on it. And he has to protect that sort of that as property. It's not property. It's just code. It's infinitely replicable with computers. So, once you scratch under the surface of any of these kinds of, philanthropy ideas, not all of them, of course, but most of the big ones that we talk about, there is a voracious, self-aggrandizing capitalist underneath it. So, if that's what we're talking about, then yeah, it's quite horrifying and it's obscene. I keep using that word because it's important to make it clear to people that what we're experiencing right now is not good. It is not a good idea. It is not a good thing that 50% of the voting U.S. population decided to re-elect a literal fascist as president. That is not a good thing. That is not okay. And we should not allow it to be so. And so it's important to use very clear moral language when we talk about these kinds of things. But it's also obscene that we are simply giving space, the moon and Mars to these wealthy private individuals and corporations. So I think that, part of the reason that, one of the things that we can do, of course, is have conversations like this and make sure that people realize that no, in fact, it's not okay. What we're seeing here is not okay. It's not valid. It should not be valorized. And in fact, we should not celebrate it. We should criticize it. And the fact that, people, there's always a kind of backlash to the backlash, right? That means that, the capitalists are always winning, and they're doing, much, much better than a lot of people expected them to do. And so, when someone criticizes Katy Perry for this kind of theatrical, kissing the ground and that kind of a thing, that's totally valid. She should be able to be criticized, and we should be able to, excoriate these people for this explicitly capitalist advertising theater.
I was just surprised she wasn't looking out the window. she was looking at the camera and a flower, and I thought, the planet is behind you. If you're going to do this, at least look in that general direction.
If there's one single experience that a human could ever possibly have that could take their eyes away from their selfie camera, that should be it.
Yeah.
But it wasn't.
Just that what do they call it? The overview effect, right? The overview effect, just passing Katy Perry by, this possible profound moment of self-reflection. But she didn't need to, because she probably already had it planned to say that we're all one, we're all connected. But she could have felt it. She could have experienced it if she just turned the other way, maybe.
That's why it's not to cut you off, but that's why the other experiences, right, by people that have gone to, again, it's very low orbit, but people that have quote unquote gone to space are much more powerful, right? When you have, even for me, like, if you have a space tourist who just happens to be one of these kinds of like, under the radar rich people, and like, they come back and say crazy things like, wow, that was really cool, not trying to advertise themselves too much, or not trying to do this theatrical stuff. That's much more powerful. I mean, it would be much more powerful if you had, like we said, some regular people that were able to go up and come back and express, because that's the thing about astronauts. Basically, every astronaut that has gone up to, gone to space and spent any time, they come back and they end up saying some very weird things, because it does really change your experience and your perspective. And that's what I would like to see. And if you don't see that, if you see a very highly stage managed version of this, it's a dead giveaway that this was an advertisement more than anything.
Yeah. So, okay. So given that, we've given the state of the world, the fact that maybe things for a lot of people are feeling a bit disastrous. The planet's not necessarily in the best shape. Things are feeling a bit absurd. There was lots of things I wanted to ask you, and I hopefully maybe one day you will come back and I can ask you more. But to wrap it up, given the state of those things, and that some people may be, finding it difficult in their day-to-day lives. Back in the day, maybe we used to look up at the stars and wonder sort of what could be at that universe when we could see them, because we didn't have the light pollution. And maybe there's a kid somewhere looking at the breadcrumbs of his mum's freshly baked bread, wondering, something more about what reality is. What advice do you, from living your life, from doing your work, do you have for people about existing day to day? I'll caveat this with I work in healthcare, and I told a mental health nurse who I work with that I was having this conversation. I was very excited, and he said, "I've got a question." He said, "How does all of that stuff help me?" And I think it touches on kind of what we're, in a way, the kind of question we're asking of Bezos, and I'm sure it does, but I kind of want to ask you, what advice do you have for people that maybe feel a bit sort of disenchanted with just the state of things in a more general way, disappointed maybe? And how does particle physics, how does the work that people are doing at the Large Hadron Collider and the work that you're involved in, how can it help everyday people?
It's an extremely good question, and your colleague is completely right to ask the question too, because from a kind of day-to-day perspective, this person could have lived their entire life and never known that it's entirely possible the universe is inside an enormous black hole, and they could have lived without ever hearing about the Higgs boson, and they could have lived their entire life, and in fact, people lived their entire lives before the 1930s. Not knowing about quantum mechanics, not knowing about any of these kinds of things. And they still had meaningful lives.
I just want to say very quickly as well. I might have toned it a certain way, but he's a massive he's a massive Star Trek fan. He's curious about these things. He wouldn't have been saying it from a negative, how can this help me standpoint. He's curious. He says, what I love is finding out these people from these different perspectives, and I want to know what can I implement into my life. What is that is going on there that can is affecting my life, right? So yeah, it was
Yeah.
coming from a good place.
Well, the answer is that whether or not the person is coming from a dour perspective or kind of like an enthusiastic science-minded perspective, I can still address the question both ways. Because if you're coming from the kind of the enthusiastic science perspective, you have I would ask back. I would say, where does curiosity itself come from? Because the fact that you're even asking this question, or the fact that you're even interrogating why someone would do a certain type of research or study a certain kind of thing and what it might mean for a person's life, means that there's some curiosity there. And where does curiosity come from? It comes from a gap. It comes from an abyss. We talked about an abyss earlier. It comes from the fact that I, as a human, and every single human has this, I, as a human, have a certain understanding of the way that the world works around me. I have to, otherwise I wouldn't be able to walk around. And then sometimes I will experience or learn or hear about something that does not match up with that understanding. And that gap that's created is the source of curiosity. It's where this, curiosity, like, oh, I wonder what this could be. There's a dissonance there. There's something that does not fit with what I currently, quote unquote, know. So when you have curiosity, that's your brain trying to better understand the way that the universe works. And in fact, we all have this in smaller ways. We've done, as a child, we all had this kind of like, childlike curiosity. That's why it's called childlike curiosity. That then, some of us go in certain directions in our lives, and it gets sort of watered out, washed out and watered down. And I think that, if you are still a kind of person that can look at all the kinds of sciences and think, wow, this is fascinating, I want to know more about this, then you still have that kind of kernel deep down inside you that in and of itself has value. Because what it does is it allows us to better understand our human place in the universe. We go full circle to the original sort of topic of the conversation, is that does science have a kind of disenchanting effect upon the world, or this sort of Jungian notion of a disenchantment in a way? Even if that's the case, and again, I don't necessarily think that's the case. I think we kind of have to take the question, twist it a bit, and think of it from a different perspective. But even if that were the case, there's still so many things that we don't know about the universe. There's so many things that are still there to learn. There's so many things that are unknown that science, that's why there's never going to be an end to science. If anyone ever tells you there's going, well, we're reaching the end of science. Once we, figure out what quantum gravity is, that'll be the end of physics. That's not true. Every time we learn something new, it answers one or two questions, but then it typically opens up 10 or 20 more questions. That's always the case. The Higgs boson, for example, we discovered the Higgs boson particle in 2012. It answered only one question: does a particle like the Higgs boson exist? And it opened up about 20 other questions that we're still going to be answering for the next several decades, right? This is fascinating in and of itself. And having a chance as a human to be on, even briefly during this tiny amount of time that we exist in the universe, a single life, having a chance to be on this wheel of curiosity, this wheel of research, this wheel of scientific inquiry, is extremely precious. And that to me is enchanting. That to me is absolutely just gobsmacking. The fact I find myself, sometimes I think of myself as a cool guy, and I think I get a big head, but then I will look up at the sky, or I think about the types of things, the questions that we could answer that we will never be able to answer in my lifetime, but somebody somewhere in the future will be able to answer that. It's simultaneously terrifying, but also extremely humbling. I think, wow, the fact that I am part of this wheel of inquiry, even right now, even for a tiny amount of time, is absolutely precious. And to me, it makes life a richer place, a richer thing, and it makes the world a richer place to live. In a practical way, for example, the existence of the Higgs boson affects your day-to-day life, because if the Higgs boson, for example, discovery is proof positive that something called the Higgs field exists, And the Higgs field is this invisible jelly that permeates all of space everywhere. And you don't feel it, but some of your elementary particles do. And as they move through this jelly, a little bit of their energy of movement is stuck into a point that we measure as mass. And that's where the concept of mass comes from. And for example, every electron in the universe, your body is swarming with electrons. Every electron of the universe has the same mass due to the Higgs boson particle. And that's a very good thing, because if the electron didn't have a mass, if this Higgs field didn't exist, the electron would have a zero mass. And if electron had a zero mass, atoms would never have formed in the early universe, and you and I would not be here to have this conversation. So it's very good that we do this kind of research, and it affects your life in a day-to-day in that way.
That was possibly the best answer you could have given to that question, which was existence itself would cease to be. I will take that back to him. I will make him aware. James, listen, I thank you so much. I really appreciate you coming on. This has been so interesting. A lot of it, like I say, these ideas, they are very difficult to grasp for a lowly human like me, a mere mortal. But you do make it very accessible. So I would really encourage people to go and check out your work. I think, what you're talking about, this idea that, I think to be re-enchanted is everywhere. And this idea of to be part of the... what did you call it? The wheel of
scientific inquiry.
Yeah, of scientific inquiry. Knowing your place in that, knowing that these things maybe one day will be discovered. It's it's a beautiful thing, I think, to think the sheer audacity of human beings to say, these are some, near on impossible questions, but by golly gosh, I'm going to give it my best go to figure out how to do that. I think if you reflect on that, just me reflecting on it in this podcast as you talk about it, it is really a beautiful thing. It's almost poetic, the sheer magnitude of that and the willingness to attempt it, to attempt it and to be a part of that. So thank you for bringing those insights. Thank you for telling us more about the kind of, I don't want to say nuts and bolts, because we've talked about the importance of rephrasing our questions correctly and using our language correctly. And that's, again, something to reflect on. But where can people find you right now? Where can people engage with you more currently on, social media, things like that?
Yeah, so I'll mention that I do have you can, as you mentioned, you can find a lot of my talks online. But primarily what I've done over the years is I've built up a kind of a strong, interest and practice in speaking on stage. So I like to speak on stages, and as you pointed out, it's more like kind of science storytelling in a way, because I have a background in film. And so I like to do sort of like cinematic versions of telling science stories and bringing in the big questions and also the big science and cool stuff. So I typically speak on stage. I don't use social media a lot. I haven't done a lot of it. I do have a fairly large following on TikTok, and people can find me there, but I don't use it so much anymore. I'm a very busy person. Nothing against social media. It's a lot of fun, but just there's only so many hours in a day. So people can find me on TikTok. They can find me. I tend to do spontaneous live streams sometimes, which is a lot of fun. If I find myself in front of something really cool, I'll just come on and start answering questions about the universe. But I also do have a book proposal in the works. It's only the proposal stage. So once people, once that gets to the full and complete, it's ready to be written, then I'll let people know. You can go to my website, jbbeacham.com, and you can sign up for occasional announcements and newslettery stuff there. You can just find me online. You can also shoot me an email if you want to ask me questions about the universe. I'm happy to answer if I have time.
There you go. Just send an email and you get that. Answers about the universe. That is beautiful stuff. James, again, thank you so much for your time. Like I say, fascinating. And I really love the way you deliver this stuff, because it's not easy to unpack it, but you're right. People should be asking those questions. Thank you so much.
Thank you so much for having me. It was my pleasure.